Right now we are looking at this question is for percentage purity for 10 marks. You are given reaction 1 and reaction 2. Right, so when you are given 2 reactions, this is what you need to do. Okay, you look for a reactant that appears both sides in reaction 1 and reaction 2. That reactant will be the excess reactant. Okay, so you have this and you have this there. You see, it's HCl, the excess reactant. Now, when you look for that substance, you have to calculate the number of moles for HCl in this reaction. Then you calculate the number of moles of HCl in this reaction. Make sure you do that. You would have solved 80% of the question. You would have solved 80% of the problem, okay? Right. So let's get into it and see what is happening. The aim, I want to find the number of moles for here, calcium for hydrochloric acid here, and hydrochloric acid there. In that case, I would have solved 80% of that problem, of the problem. So they say that we are given 2.8 grams of impure sample of sodium carbonate. It's reacted with 100 cubic centimeters of 0.5 mole per cubic decimeter of hydrochloric acid or hydrochloric acid. All right. So for hydrochloric acid, we are given 100 grams, 100 cubic centimeters, that is volume. And we are also given the concentration thereof. The concentration, I can say 0.5. It's 0.5. It's the same as saying 0.5 mole per cubic decimeters. Per cubic decimeters. Okay? Mole per cubic decimeter. Now, I'm going to find the number of moles for HCl. Then come here, get the number of moles of HCl. Okay. So let me check. They say after the reaction is complete, the excess hydrochloric acid is neutralized by 36 cubic centimeters of 0.25 mole per cubic decimeter sodium hydroxide. So we are given information about sodium hydroxide. You're given the volume, which is 36. You're given a volume of 36 cubic centimeters. Okay. Cubic centimeters. And you're given 0.25 mole per cubic decimeters. And that is concentration. This one, this is concentration, and this is volume. But this volume must be divided by 1,000 so that it is measured in cubic centimeters. I mean cubic decimeters. So 0.036 decimeter. Should be in decimeters. Now from here, I know this information, but the aim is that I must get this information of hydrochloric acid. So what I will do, I will use this information that I'm given of NaOH, this one, to get the number of moles. Then use the ratio to get the number of moles of HCl. Use the ratio to get the number of moles of HCl. Then in this step, already then I have information about HCl. I use this information to get the number of moles of HCl. So I get number of moles of HCl in reaction 1. I get the number of moles of HCl in reaction number 2. So you must calculate the number of moles of the one that is repeating itself in both reactions. When you have got two reactions, you would have solved 80% of the question or the problem given, right? So these 100 cubic centimeters must be divided by 1,000. So let's start then. We'll start from reaction 1. I will say the I'm given concentration. I'm given 100 grams. Sorry, 100 cubic centimeters. 100 cubic centimeters. This 100 cubic centimeters, you divide it by 1,000, so that it becomes 0.1. That would be 0.1 decimeters, cubic decimeters. Now I say concentration is equals to number of moles over volume. This is equals to the concentration. The concentration is 0.5 is equals to number of moles over 0.1. Then the number of moles is equals to 0.05 mole of HCl from reaction 1. This is from reaction 1. From reaction 1. Okay? Then from reaction 2 now, in reaction 2 we are given this information about the Na. So I'll get the number of moles of Na first. So I'll say concentration is equals to number of moles over, get the number of moles. The concentration is 0.25 is equals to the number of moles over volume, and the volume was 0.036. Then this is equals to then we got this number of moles for Na, for NaOH. Now we must use the ratio now, since we must use a ratio. Okay, we got the number of moles here. Let me continue on the next page. So my calculation was as follows. I calculated in reaction 1, I calculated the number of moles of HCl. Then in reaction number 2, I calculated the number of moles of NaOH because I had information about it. Right. Now I'm going to get the number of moles for HCl. Remember, when you're given two reactions, you must get the number of moles of the one that is repeating in both reactions. You must get you in that way you would have solved 80% of the question of the problem. Okay. Now let's do it. I'm going to use ratio to get there. Use ratio. Now the ratio is HCl is to NaOH. Okay, is 1:1. The ratio is 1:1. So NaOH is 0.09 mole, which means the number of moles of HCl, because it's 1:1, it is the same as the ones for NaOH. So the number of moles of HCl will be that. Right. Now I start classifying this number of moles. This number of moles that I've calculated for HCl is the initial number of moles. This number of moles that I've calculated for HCl here is the excess number of moles, the number of moles that were left over. Right. Now, what I need to do is, the question, remember, it says we must calculate the percentage purity of the substance. The percentage purity of the substance. Now, since HCl is the excess reactant, very important, let's listen. Since HCl is the excess reactant, you cannot use the initial number of moles of the excess to get the number of moles of this substance here using ratio. I cannot use ratio and initial number of moles of the excess reactant to get information about another substance. I can't use ratio here, okay, because the initial number of moles mean it is not all the number of moles of the initial that will react completely with this substance. Not all the amount for the initial will react completely with the sodium carbonate. Okay. Hence, for the excess, that's why this is excess. Excess has got initial, it has got reacted, and it has got left over. So it has got three number of moles. So it is not all the initial that reacts completely with that. It is a certain part of moles. It is a certain amount of moles out of this initial that react with that. So now, to get information about another substance, if you have got information about the excess, you must get the reacted number of moles of the excess. So I say the excess has got three number of moles. It's got initial, it has got reacted, and it has got unreacted. unreacted or excess. Right. Initial number of moles cannot be used in ratio. You can't use it with a ratio. You can't use this with a ratio. The unreacted, you cannot, the unreacted number of moles. So the only number of moles that we are allowed to use in a ratio is the reacted number of moles for the excess reactant. This is about excess reactant. It has got initial, reacted, and unreacted. But the number of moles that you should use in a ratio so that you get information about another substance is the reacted number of moles. And in this case, we have unreacted number of moles, we have initial number of moles. What do you do with the two number of moles? You subtract them. You subtract them. So in summary, what am I saying? In summary, I'm saying this is what you need to do for percentage purity. Okay, you need to do this. The substance that is repeating, okay, you get number of moles of the substance that is repeating. When you have two reactions, you get the number of moles of the substance that is repeating, you get the number of moles of the substance that is repeating. Then, in reaction 1 and reaction 2, those number of moles that you are getting, you subtract them. In that way, you will get the number of moles that reacted for the excess, okay? Or for the, or I can say for the HCl, okay? I'll get the number of moles for the excess reactant or the H, which is the HCl. Now, after getting those number of moles that reacted, you now use ratio to get information about the mass of Na so that you can calculate its percentage purity. Okay? So we are now going to say the number of moles that reacted for HCl is equals to initial number of moles minus the unreacted or the leftover, in other words, the ones that are in reaction 2. The unreacted number of moles, or the ones that are in excess, in other words. So minus the ones that are in excess. Okay. Now this is equals to, those two number of moles are the number of moles of HCl. This one is initial 0,05 is initial number of moles. Then minus 0.009. Then this is what we get. You are going to get 0.041 mole of HCl that reacted. Now, you're going to use ratio now to get these ones. Now, I have to do this now, okay? I got the number of moles that reacted for HCl, the number of moles that reacted. Those number of moles, N is equals to 0.041. This number of moles, I'm now going to use a ratio to get information about this one. Right, to get the ratio between these two. You get the ratio is you get the ratio is 1:1, as indicated, right? So in front here is 2, in front here is 1, as we can see. Right, now we say we divide here. We divide it by 2, both sides there. Divided by 2, divided by 2 then. Then n is equals to 0.0205 mole of sodium carbonate. Okay. Right. Now I must get the mass, which is the pure mass of sodium carbonate. The pure mass will be N is equals to mass over molar mass. 0.0205 is equals to mass over. In your calculator, you determine the molar mass of this substance. If you calculate the molar mass of sodium carbonate, the answer that you will get is 106. Is the molar mass. 106 is the molar mass of sodium carbonate, this one. Then you say 108, you cross multiply the you get the mass of 2,173 grams. Right. Now to get percentage purity, so let's check what we did there. I said you get initial, I'm starting from the beginning now to explain what I did. Okay, HCl is there here and it's also there in reaction number 2. All right. The aim, get the number of moles for the substance that is repeating, which is HCl in this case. Get the number of moles of HCl in reaction 2. Now, those two number of moles, when you get percentage purity, you must subtract them You subtract them, the two, you subtract the two number of moles, then you'll get the reacted number of moles. Now, after getting the reacted number of moles, okay, you now use the ratio to get the pure mass. To get the pure mass. Right. Then the pure mass, we got it as 2,173 grams. This, so we put 2,173 over the pure mass was what was the impure mass, by the way? No. Okay, where are we? Okay. The pure mass, so it is 2,8 was the impure mass. Okay, so the impure mass is 2,80 times 10 to the power. This was just information. Then we punch our calculator to get the percentage purity. So the percentage purity is this one now. Although it's a long calculation, I think it's a simple calculation because check, this is what I just said to you. You check the substance that is repeating both sides. Check this substance that is repeating. You get number of moles in reaction 1. You get number of moles in reaction 2. You now subtract those two number of moles. So in reaction 1, you get number of moles. In reaction 2, you get number of moles of that substance that is repeating. In this case, HCl. We are talking about the reactant, the substance that is repeating on the reactant side. Then now I say the number of moles minus the number of moles of HCl. Again, these ones are from reaction 1, these ones are from reaction 2. That will be the reacted number of moles. That will be what we call reacted number of moles. Then you use ratio now. You do ratio. Say, okay, the pure substance is to HCl, which is the excess reactant. In this case, the one that is repeating. You do ratio. You do ratio with them. Okay, using which number of moles? Using this number of moles here. So for HCl, you use this number of moles there. Then you'll get the number of moles of the pure substance. You'll get the number of moles of the pure substance. Then now use N is equals to mass over molar mass to get the mass of the pure substance now. You get the mass of the pure substance. Now to go to percentage purity, we say percentage purity, the percentage purity is equals to the pure mass that you got divided by the impure mass that they gave you times 100%. Then that's what you actually do. Reaction 1, reaction 2, for the substance that is repeating, subtract those two number of moles to get the reacted number of moles. Then you do ratio with the pure substance, okay, using the reacted number of moles. Then you would find the number of moles of pure substance now. Now you get the mass of the pure substance using this form. Then you come to percentage purity.